Hi guys, sorry I can't be with you today, but Miss P's there with you, so just let her know if you need to pause the video at any point to take notes, or if you need to back up the video, just raise your hand, she can do that for you. Let's go ahead and get started though. We are starting Chapter 8, which is on applying equations and inequalities, and we are on 8.1, simplifying equations, which starts on page 312. So, up to this point we've done simplifying expressions, and we've done solving equations. So now we're going to combine the two different things. So I have already kind of put the text in here so we can follow along, and then I'll show you some examples. So it says, in Chapter 3, you learn that the commutative property and associative properties allow us to group like terms together. Remember, the commutative property tells us we can change the order of things, and the associative property tells us that we can regroup or change the way things are associated with each other. Then we've also used the distributive property, and says the distributive property permits us to combine like terms. The result is a simplified equation that can easily be solved for the variable. So we've been using the distributive property, you may not even realize every time we use it. But just to review, the distributive property tells us if we take a times b and a times c, we just keep that plus sign and we get ab plus bc. So it says the following examples review the use of the distributive property. This is how we've been using the distributive property so far. This is example number 1. It says simplify 5y plus 2 minus 6y plus 14. Now when we've been doing these, we have been just combining our like terms. So we have our 5y. Remember, we have the negative 6y because this is like saying plus a negative. Then we have a positive 2 and we have a positive 14. So we're going to combine these things. When we start combining, we have 5y minus 6y. This is a way we can just regroup or change the order of things so that they're close to each other. So we have the 5y and the negative 6y, that negative. And then we have the plus 2 and plus 14. So far we've just kind of reordered them so that it's easier to simplify them. When we're combining our like terms, we have the positive 5y and the negative 6y. This is where the distributive property actually comes in the background, even if we don't realize it, because we're singling out the 5 and the negative 6 and combining those and keeping the y. So if we saw the distributive property happening right now, it would look something like this. It would look like 5 minus 6 and then the y. So this is where we're kind of like doing a reverse distributive property. We're pulling that extra y out of there so that we can combine the 5 and the negative 6, or 5 minus 6. So when we do 5 minus 6, we get negative 1, and then we still have that y. And then we have our plus 2 and our plus 14, which would be plus 16. And we can simplify this even further by saying negative 1y, well, the 1 becomes imaginary, so it's just negative y plus 16. So this is how we've been using the distributive property whenever we're just simplifying, or simplifying we always say is like saying combine like terms. Example 2 then. This time we're going to combine our like terms first, and then this is an equation, it has an equal sign in it, so we're going to solve. So we have our 8x and our negative 4x. So again, if we were noticing the distributive property actually happening right now, we would see this is like saying 8 minus 4, and we're keeping that x because that's our like term. 8 minus 4 is 4, and then we have our x. Copy down the rest of the problem. We have plus 6 equals negative 86. So at this point we just have a two-step equation. So we have to remember, how do we solve a two-step equation? First of all, you have to remember we have you and your best friend hanging out here, and you have your annoying little brother. So who are you going to send home first? Your annoying little brother who does their adding and subtracting. So we have plus 6. The way to get rid of a positive 6 is to subtract 6 from both sides. So we're left with 4x equals negative 92. Then when it's finally time for your best friend to go home, you divide by 4 because it's 4 times x. We do the opposite. And we end up with x equals negative 92 divided by a positive 4 is going to give me a negative and 23. You should always go back and check, of course. So if we were to check this, we take our 8 times our negative 23 minus 4 times negative 23 plus 6 equals negative 86. You can punch all of this in your calculator and you'll find out that negative 86 is equal to negative 86, and it does check out. Whoops. I don't want you to see those answers yet. I want you to go ahead and try simplifying and solving for skill check 1. Now, Miss P is going to be walking around to make sure. You must do these in your notebook. You can't squeeze them into your textbook because each of these has multiple steps, especially the solve ones. So you do have to do these in your notebook. And if you'd like to use colored pencils still to help you with combining your like terms, you're more than welcome to. Go ahead and do 1 through 6, skill check 1, and then whenever you are all done, Miss P will unpause the video so that you can see the answers. Okay, so here are the answers for skill check 1. Once you go ahead and pause the video again, check your answers. If you have any questions, make sure you make note of them. You can always email me your questions later if you're still having trouble with these. Okay, then moving on. It says before combining like terms in an algebraic equation, such as 7 times x plus 3 plus 5x equals 69, you must remove the parentheses. So this is where we're going to use the distributive property that we're probably a little bit more familiar with. So the first thing we have to do before we can solve this equation is distribute this 7 to get rid of the parentheses. So when solving an equation, if there's parentheses, you have to get rid of those first. So we're going to take 7 times x, and we'll get 7x, plus 7 times 3 is 21, plus 5x equals 69. By the way, this is your example 3 on the next page. So once we've distributed, a lot of times there's going to be like terms to go ahead and combine. So when we're combining these like terms, we have a 7x and we have a 5x. A 7x and a positive 5x will give us 12x. Then we still have the plus 21 equals 69. And then once again we're down to a two-step equation. All we have to do is get rid of our 21. It's a positive 21. It's my annoying little brother or sister. I'm going to get rid of them first, so I'm going to subtract 21 from each side because that's the opposite of adding 21. So we will be left with 12x equals 48. And then to get rid of the 12, it's 12 times x, so we're going to do the opposite of that, which is divide. So we're going to divide both sides by 12, and we will get x equals 4. Once again, you should always check this. You would check it just simply by saying 7 times 4 plus 3 plus 5 times 4 equals 69. So every time I see an x in the original equation, I'm just going back and putting in my new x value, which is 4. So then we use our order of operations. So 4 plus 3 is 7. Seven times 7 is 49. Plus 5 times 4 is 20. And 49 plus 20 is 69. So we have 69 is equal to 69, and that is true, so it does check out. Next up is example 4. Now I know it's in your book. If you want, you can pause it and try it, and then watch me explain it. Make sure you're on the right track. Okay. So let's go ahead and try this one. When I see an equation that has parentheses, the first thing I have to do is get rid of my parentheses. This is something that's probably going to be note card worthy. First thing, get rid of parentheses. And I do that by using the distributive property. But make sure you notice on this, there's a negative sign or a minus sign in front of this 9, which means I'm not just multiplying by 9. I'm multiplying by negative 9. So when I distribute, I'm taking negative 9 times y, which gives me negative 9y. I'm taking negative 9 times 4, which is going to give me a negative 36. Then I continue with my problem. So I have 20 minus 9y minus 36 equals 2. My next step is to check to see if I have any like terms to combine. So step 2. Combine like terms. It's important to remember that this is an equation, so you're only working on one side of it. So even though I have a 20 and negative 36 and there's this 2 over on the other side of the equation, that 2 is on the other side, so it's not part of the like terms that I can combine. I just have the 20 and the negative 36. So I have a positive 20 and a negative 36, which is going to give me negative 16. And then I will just copy down the rest of my problem. So I have negative 9y minus 16 equals 2. And then I'm just down to a two-step equation. So my next step is just simply to solve my equation. So I have negative 9y minus 16 equals 2. Get rid of the 16 by adding 16 to both sides. So I will end up with negative 9y equals 18. Divide both sides by negative 9 to get rid of the negative 9. I end up with y equals negative 2. Then of course we should go back and go back and check one more time just to review how to check. Do 20 minus 9. Anywhere I see y, I put in a negative 2. And then make sure that it comes out to be equal to what's on the other side of my equation. So I have 20 minus 9. We could distribute this here, or we can just follow our order of operations, which says do the parentheses first. So negative 2 plus 4 is 2. Negative 9 times 2 is negative 18. And then we'll have 20 minus 18 equals 2. And 2 does equal 2, so this does check out. So sometimes you will see a set of parentheses that won't have a number in front of it. And what we need to do is remember that when there is not a number in front of our set of parentheses, it's like there's an imaginary 1 there. So we're actually distributing an imaginary 1. So when we have 9x plus 3x minus 2, or the quantity of 3x minus 2, we're distributing 1, and that is how we drop our parentheses, because remember, the first step is get rid of your parentheses. So we'll just end up with 9x plus 3x minus 2. And then we should always finish by simplifying it, so we'll just combine our like terms. And that gives us a 9x and a 3x would be 12x minus 2. So this would be simplified for us. Also, it says if there's a negative sign or a minus sign in between or in front of the parentheses, we need to treat that like it's a -1 being distributed. So there's an imaginary 1 still there, but this time it's negative, so it's a -1. So we've got to remember that negative, so it's a -1. So when we distribute this one, we'll have -1 times 2x, and -1 times this would be a -4, because this is a -4. It's the same thing as plus a negative. So when we distribute, we end up with 5x, -1 times positive 2x is minus 2x, and -1 times -4 is plus 4. So we've gotten rid of our parentheses, now we just have to combine our like terms. So to combine our like terms, we're just saying 5x and -2x is going to be equal to 3x plus 4. That brings us to example 5. So example 5 is just like the one I just did. So I want you to pause the video and try it on your own. Try not to look at the book, and then have Miss P push play and see how you did. Okay, so to distribute, we have to remember there's an imaginary 1 in front of this negative sign, or in front of the minus sign. So those are glued together. So when I distribute this, I have -1 times 4x and -1 times -9. So I'll have 18 minus 4x, and -1 times a -9 is a positive 9. And we just have to check to see if there's any like terms to combine, which there are. 18 and 9 give us 27. We'll have 27 minus 4x. Or, if we're writing it in the proper order, it would be -4x plus 27. But either of these answers would be acceptable. It does go on to say that when this process is understood, you don't have to write that -1 in there to distribute it to get rid of your parentheses. But we still do it in Algebra 1. I still do it just to make sure to check myself also, so I would not take any shortcuts. I repeat, do not take any shortcuts. Just go ahead and still draw that imaginary 1 in and distribute it so that you make sure you're not making any mistakes. So, example 6. It says solve 9 minus x plus 8 equals 20. So the last couple examples, we were just getting rid of our parentheses or distributing, and then combining our like terms. We're just taking it a step further now by actually solving. So first things first, get rid of parentheses. We're going to do that by distributing our imaginary -1. So -1 times x gives us a negative x, and -1 times a positive 8 gives us a negative 8. The rest of the problem we can just copy down. So we'll have 9 minus x minus 8 equals 20. Try to remember what's our next step. Our next step is to combine like terms. We have a 9 and we have a negative 8. So 9 and negative 8 is 1. Then we have a negative x equals 20. And then our last step is to solve. Well, this is backwards from what we're used to seeing it. We can still solve it. We can just say, well, this is a positive 1, so we're going to do the opposite and subtract it. And this is a negative x, or there's an imaginary 1 in front of it, so we could divide. Or, if you prefer, if it makes it easier for you, you can flip these around, because remember we have the commutative property that tells us we can flip these two things around. So it would just be negative x plus 1 equals 20. That's an extra step. It's not required. It just makes it a little bit more plain for us to see what's going on. So to solve this one, we're going to subtract our 1 from both sides. We get negative x equals 19. And then remember, this x is not all by itself yet. We have to get x all by itself, but there's an imaginary 1 here. So we're going to have to divide both sides by an imaginary 1, which gives us x equals negative 19. Of course, you should go ahead and check this. I think we've checked enough of them to know the checking process. And we can also just check in our book for right now to see that it is x equals negative 19. However, on your test and on your homework, you really should be checking these just to make sure. And then our last example is example 7. It's another one just like we were doing. So I would pause it and ignore the book and try it on your own, and then I'll solve it for you. Okay, so last one. Remember we have a positive imaginary 1 in front of our parentheses. So to get rid of the parentheses, we're going to distribute that. So positive 1 times 3x is just 3x. Positive 1 times 4 is 4. You can copy the rest of the problem down. So we'll have the 5x plus 3x plus 4 equals 40. The next thing you should have done was combine your like terms. So I have a 5x and a 3x for a total of 8x plus 4 equals 40. And then the last thing I would do is solve. So I have 8x plus 4, so I'm going to subtract 4 from both sides to get rid of that. So I'm left with 8x equals 36. And then to get rid of the 8, it's 8 times x, so the opposite of that is to divide. So we're left with x equals 36 over 8. They did it as a decimal, which would be 4.5. That's one way to answer it. Or you could leave it x equals 36 over 8, but you would have to put 36 over 8 in lowest terms. So they both have 2 in common. And then they both have 4 in common. So you could also have, let's see, 36 divided by 4 is 9, and 8 divided by 4 is 2. So you could have 9 over 2, and that would be fine also. Just remember, we like to leave our fractions as improper. But they do have to be in lowest terms. And then you should check this back out. Again, you can put the 4.5 in for each of the x values and solve, and you will get 40. Alright, so go ahead and try skill check 2. Have Miss P pause the video now, and then you can come back and check your work. Alright, here are your answers for skill check 2. Again, if you have any that you're confused on, make note of it. Tell me like 1, 2, 3, or 4, and then I want you to email me. Miss P will go ahead and give you your assignment. And then here's my email address, just in case you have any questions. Do not hesitate to email me. I will check it this afternoon if I can, or definitely this evening. Just email me from whatever you're going to check at home so that I can get back to you. And then I'll see you guys tomorrow.